me just share my screen. Let me know if you guys are able to see it.
We can see it now.
Okay. So I'm here in my remix. I'm going to create another contract. Let's call it. Okay, let's make a token. Right. What should we name our token? What should we name our ERC20 token? Uh, let's say LW3 builders or something. I don't know. Okay. So I'm going to just jump into the code right away. Let's define our license here. SPDX license identifier MIT. Then we have the compiler version, pragma solidity 0.8.7. Okay, so then let's call what we are going to let's call our token LW3 builders. So I'm going to name the contract as well, LW3 builders, right? And then actually we are going to make an ERC20 token, and the ERC20 token contains a lot of code, right? uh, so we don't want to write all of that code. So what we can do is we can import that code from the Open Zeppelin's contracts. They have already written that code. We can just inherit that. And the way we inherit another smart contract in our Solidity is by using import keyword, right? So we can say import, and here we can just type out the URL where the code is hosted. Here we can give the GitHub URL, right? So I'm just going to come here in my already created cryptocurrency. So here is the import statement, right? We are just going to paste that in. There you go. So we have Open Zeppelins. We have imported this file, right? Now, and if I go to if I search for this URL, you can see this is a huge file. All of this is the ERC20. This is the ERC20 standard, right, by Open Zeppelin. So they have already created it. We don't need to reinvent the wheel. We can just use that, right? And in this ERC20 standard, they have a mint function, right? And we can actually use that function in order to mint some ERC20 tokens. This function we are going to use in our smart contract when we want to mint that function, right? So when we want to mint those tokens. So I have imported this smart contract in our Solidity file, and I'm going to call the contract LW3 bidlers. All right. So let's create a constructor here, constructor function, and our constructor function will take two arguments. The first one would be a string which you are going to store in memory, and let's call it the name, right? The name of our ERC20 token. And another argument that it will take is that would be the symbol of our ERC20 token, right? So our constructor will take these two arguments, and further what it will do is if you go to this ERC20 standard and search for its constructor here, you can see that the constructor of this ERC20 standard also takes two arguments. That is, the first one is the name and the another one is the symbol, right? So what we will do is we will take these arguments from our user, from the deployer in our constructor, and pass it further to the constructor of the ERC20 standard, right? So here in the ERC20 we'll say we'll pass these name and the symbol, right? So that's what we'll do here. And then in our constructor we are going to use the mint function which is declared in this OpenReply ERC20 standard. Now we can use this mint function now. Why we can use this? Because we are inheriting from this smart contract, and actually we have to say contract LW3 builders is ERC20. This is how you inherit from the smart contracts, right? So basically what this import statement will do is it will import all the code written here in this file. It will import all the code in here in this file, right? So when the compiler will compile this code, that code will also contain all of this code, right? So basically just imagine that instead of this one single line you have all of this code here, right? So that's what this import statement is doing. And in our contract, what we are saying then that our LW3 builders contract is ERC20. So that means that our LW3 builders contract is inheriting all the functions, everything which is declared in this smart contract. So now since this function, this contract LW3 builders inherits from ERC20, we can use the mint function which is defined in this ERC20 standard, right? So as you can see that this mint function, this mint function also takes in two arguments. The first one is the address, that is the account to which we want to mint our ERC20 tokens, and another argument which is a uint, and that is the amount that we want to mint, the amount of tokens that we want to mint, right? Okay, so let me just right. So in our mint here, what we are going to do is we are going to in our constructor we are going to mint some tokens to the deployer, right? To the message.sender. That means the person who will deploy the smart contract, we are going to mint some tokens to him, and the amount that we want to mint is up to us. Let's say we want to give them 10 LW3 builder tokens, right? So we are going to say 10 times 10 to the power 18. And why is that so? Because this value is in way, right? We are supplying the value in way. So one way is equal to, sorry, one ether is equal to 10 to the power 18 way. So basically this means we are minting 10 LW3 builder tokens, right? To this message.sender. That means to the deployer of this smart contract. And that's what it is basically. And you see how simple is this to create an ERC20 token. We are also going to import this in our MetaMask, right? So actually let's take it to okay. So firstly I'm going to deploy this, and then what we are going to do is we are going to upgrade this a little bit, right? So let's compile this now, and it's getting compiled. Okay, it's compiled now. Let me come to my deploy tab, and we are going to deploy this on an actual test net, right? So I'm going to open my MetaMask, transaction is confirmed. As you can see, the contract is deployed, right? Now what we can do is, okay, let me just share my whole screen so that you can see the MetaMask. You can see the tokens in my MetaMask wallet.
I think you can leave it as it was because we were able to see the MetaMask notification pop up.
You were able to see it?
Yeah, yeah.
Alright. I thought you weren't. I thought I was only sharing my browser window. Okay, so what I can do now is, now I deployed this smart contract from this address, right? I deployed my smart contract. That means during the deployment, when the smart contract was deployed, after that this constructor function was called and it minted 10 LW3C tokens to me, right? So what I can do is I can go to my MetaMask and I can, okay, let me just copy the contract address and then I'm going to go to my MetaMask and say I'm going to come to this assets tab and then import tokens. Okay, I'm going to paste the token contract address here, and as you can see, it already detected that it is the token symbol is LW3C and it is the decimal is 18. That means as you all know that it is 18 decimals, 1 is equal to 18. So that's what it is. And then I'm going to add this custom token, import tokens, and you can see that I already have 10 LW3C tokens in my MetaMask, right? And so that as you can see, we created an ERC20 token and we imported it into our MetaMask. So right now it's of no use because we are only minting the tokens on the time of deployment, right? So let's create another function which can mint the tokens on demand, right? Let's create a function, call it mint tokens, and then this function is going to take an address of the beneficiary. That means to the address of the person to whom we want to mint those tokens, right? Beneficiary, and then it's going to take the amount that we want to mint. It's going to be a public function, right? So that we can call it, and then in this function what we are going to say is we are going to mint, we are going to use this mint function which is created in our ERC20 standard, right? And as you know that this mint takes in an address and the amount. So we are going to supply the address of the beneficiary and the amount that we received, right? So yeah, that's basically it. Actually, we can take the amount in like for this function, we will have to supply this humongous amount. This should be if we want to mint 10 tokens, then this amount should be 10 into 10 to the power 18. So let's say we just want to supply here 10 in this amount, and it should already mint 10 tokens to us. So what we can do is we can say amount times 10 to the power 18 here. So we don't have to supply that humongous amount here, right? That's what we can do here now. But as you can see right now, anyone can call this function. So yeah, anyone can just call this function and they can mint some tokens for themselves. We don't want that. Okay. So we are going to create a modifier here. Actually, we can also use the require statement, but I'm preferring modifier here. So let's say we
You didn't give a modifier a name.
Oh yeah.
Yeah.
Oh, sorry. Yeah, that's why I was wondering. I did not highlight it here. I don't know. Okay. So yeah, we are going to name our modifier only owner and going to use it here. So yep, I guess that's it. Now let's redeploy the smart contract, right? I'm going to name it LW3 coin, right? And the symbol would be LW3C. Okay. So transact and the MetaMask popped up. Confirm the transaction. View on EtherScan spending right now, as you can see on EtherScan spending. Let's wait for it to get confirmed. Okay, the transaction confirmed. So we have this deployed contract. Going to copy the contract address and then come to my MetaMask. Let's import tokens from here, paste in the contract address, and it's going to auto-detect its LW3C tokens and custom. Okay, import. Now I have 10 LW3C tokens, right? And then if I come here and I mint some tokens for myself, actually, yeah, there it is, a function mint tokens. I can supply the address here. I can give my own address. So I'm going to copy my own address right here and the amount. Let's say I want to make 50 more tokens for myself. So I'm going to transact it and then let's confirm the transaction. Alright, so the transaction confirmed. Now as we can see, we have 60 LW3C tokens already, right? So yeah, we minted 50 more for ourselves. Yeah, I can supply any other address here and mint some tokens for them. You guys can you guys can send in your address if you want some LW3C coins, but they are useless and they have no utility or anything. So yep, that is it. That is the ERC20 token. Hope this is clear to everyone. Hope how it is clear how inheritance works, right? We are inheriting ERC20 standard in LW3 builders contract and then minting some tokens. Okay, let's move on to our Faucet smart contract, right? That one is also going to be very simple smart contract. So um, let's create another one here and call it faucet.solve and Is it fine? Okay. And lastly, what we'll have to do is uh, we need a way to refill our faucet, right? When it runs out of the ether. So we need these three functionalities in our faucet. Okay. So for supplying some amount of ether to our faucet, we can actually supply that amount in our constructor, right? In our constructor, we are going to make it payable, right? And then what we can what we'll do in our constructor is actually we don't need a constructor for this one. But if you really need to like supply some amount of ether while deployment, then you can use a payable constructor and just leave it empty, right? Um, and then if you want to give some amount of ether to anyone when they request, then we can create a function for that. Let's say get ether, right? We can do both functionalities. Either we can take an argument for the amount of ether that they want to that they are requesting, or we can just supply them a predefined number of ethers, as most processes do, right? Because let's say I come here to this Silky faucet here, and what they do is they just supply us with 0.5 ether, right? That's the limit. They can only supply us 0.5 ether. So we can also just set an amount here instead of taking an argument from the user, because they can request unlimited amount of ether that we might not have, right? So in a function get ether, uh, what we are going to do is we are just going to go send is equal to message dot send dot call, right? The value should be something defined by us, and let's say we'll give them 0.1 ether, right, when they request. So that value in way should be, let's see, 0.1. So this is the value, right? We are going to transfer this much amount of ether, right? Then this value is in way to them, to the message or sender when they request it. So yeah, that's what we are doing in this ether get ether function, and it's going to be a public function so that others can call it. And okay, they are saying that you are not using this send variable. So this send variable contains a value true or false if the we can supply some amount of ether while the time of deployment. So let me just showcase it to you in the local VM here. First of all, so during the deployment, we are going to supply 10 ether. Okay, and let's deploy this. As you can see, the faucet is deployed. Okay, right now we don't have a way to know about the balance of this faucet. Let's also create a helper function for that as well. Helper function, and call it get balance. Okay, get contract balance, right? And here we just return address of this dot balance, right? And it's going to be a public and view function. Okay, we also need to specify what it returns. So it returns a unit, right? Okay, compile and let's refresh our VM and deploy it again with 10 ether and deploy it. Right now you can see the contract balance is 10 ether because we passed that value here in our message.value during the time of deployment, and it was able to accept that value because our constructor was payable, right? And then we can so right now I have selected this account. It has around 90 ether, right? 89.999. Let's come to this account 100. This contains 100 ether, and now if I click this get ether function, right? You can see the balance actually increases when I click this get ether function. You can see that it is increasing, and I am getting 0.1 ether with one function call, right? So yeah, the user can just they can just call this function get ether and get that amount of ether from our faucet. That's basically it. But there is a problem with this faucet. There is a problem. Does anyone know what the problem is? So the problem with this, no, actually, for this, as user said that there is no token created, but actually we are dealing with ether here, Yusuf. So we are dealing with the ether, and ether is the native currency of Ethereum, right? So we don't need to create any token here, right? And as I don't know, okay, as this guy said that uh, that what did he say, that you can request any amount, but no, we cannot request any amount. We are not specifying any argument in our get ether function. We are just supplying 0.1 ether, right? We are just supplying 0.1 ether whenever someone requests some ether. But I appreciate your efforts. You try to like guess what's wrong with the smart contract. So yeah,
maybe one person can drain the whole faucet.
yeah, they can actually. That's also a problem with our smart contract. Uh, but basically, the big problem is that you need some amount of ether to call this function, this get ether function. You actually need some ether, right? Yeah, because you will have to pay for the gas fees in order to call this get ether function. Now let's imagine you have zero ether in your wallet. Then how will you be able to call this get ether function? You will only be able to call it if you have it already. So we have the chicken egg problem, right? So yeah, and actually this chicken egg problem cannot be solved in this Solidity code. You will actually have to write a it's not gonna work if you have 0 ether in your wallet. And yeah, also talking about that one person can drain the whole faucet. You can write the logic in your back end that if the person is requesting so much ether in such a short amount of time, you will not process his request. So all that can be done in the backend script, right? Yeah, that's it. And it was short and sweet today. Not too much, not too much coding. Yeah, so that was it. And today is our 14th day. Today is the last day of our Solidity crash course, and it's been amazing teaching you guys. I really enjoyed it. Um, yeah, that's all I have to say. It was amazing, and I hope you learned something from this. Uh, some people joined us every day. Arpita joined us every day. Srinath joined us every day. Yusuf joined us every day. I could see repeated dons joining us. Prathamesh joined us. Om joined us. And LJ, man, this guy is so dedicated. It's like 11 p.m. for him, and he just woke up like an hour ago just for this Solidity session. Even if I was teaching today, I mean, honestly, I'm not so dedicated, but I have to say that LJ is. I have to appreciate his determination. He's really getting out of his comfort zone. So thank you everyone. Thank you everyone for these 14 days. It's been amazing. Yeah, that's all I have to say. LJ, you want to say something?
Yeah, thanks for that. Yeah, it's like what is 11:12 for me right now, PM. Um, but yeah, like Sahil said, this is last day of the crash course. Um, it's really thank you for those who actually came to this every day. I know like the first few days, we had like 20 people here. Now it's like maybe 10 in here, but yeah, me and Sahil.
The first day we had more than 30 people actually. It was like 35 people. And you are the people who joined every day. So from the 35 people we have how much? 1, 2, 3, 4, 8, 11 minus the two of us. So we have nine people who were regular in these 14 days. So shout out to you all guys. Your hard work will definitely pay off. Yeah, you guys are amazing. Thanks so much. I just want to say mostly when I am attending the live chat, I couldn't follow the code, so I just watching the video most of the time. And mostly, next day I'm taking the recorded video and following up. That's what I'm doing. Hello. Wow, that's amazing, man. You are also attending the live sessions and then watching the recorded videos. Yeah, that's awesome, man. There is continuing lots of improvement after this live section because even I was before I did some videos from our freshman track. I could most of the things I get out from my memory, but refreshing the this was good. Yeah, happy to know that it helped. Yeah.
Yeah, thanks.
Thanks, man. Thanks. Om, you want to say something? Yeah. Okay.
Yeah, LJ and Sahil, great to see these sessions. I am also the one who intermittently joined the live